Okay, today we're going to be discussing distributions and what shape their center and their variability. And we also need to be reminded of the mean and standard deviation. That's how we describe the center and the variability of the distribution. Okay. Now we can really only do those if they are approximately symmetrical. So just keep that in mind whenever we're talking about this. Sample 1, we're talking about the center, the shape, and the spread. It says, have you ever noticed how sometimes batteries seem to last a long time and other times the batteries seem to last only a short time? The histogram below shows the distribution of battery life in hours for a sample of 40 batteries of the same brand. When studying a distribution, it's important to think about the shape, center, and spread of the data. So exercise 1 says, would you describe the distribution of battery life as approximately symmetrical or as skewed? So hopefully y'all remember that symmetrical kind of looks like this hump. And then if it's got a long tail either way, this would be skewed left and skewed right. And this is symmetrical. Okay, so looking at those, let's just kind of draw a smooth curve there. And I would say this is probably going to be symmetrical. That's pretty close. You're not going to have it exactly symmetrical, but that's going to be pretty close. Okay. Now, it says, is the mean of the battery distribution closer to 95, 105, or 115? Well, if we take a look, the mean is going to be somewhere let's find right in here, pretty close. 95 would be too low and 115 would be too high. So it's probably going to be around 105. Now, we know how to find the mean, add them all up, divide by however many we added up. So you could actually figure it out, but I'm just going to look at the shape and look at the data, and we can decide from there. Number 3 says, consider 5, 10, or 25 hours as an estimate of the standard deviation for the battery life distribution. Now, whenever you're talking about standard deviation, you have to remember that that is that's how we can determine the spread or the variability. That's kind of the measure that we use to just see how things are spread out. And the formula for that, if we were to sit down and actually calculate it instead of just looking at a graph, the formula is actually going to be called S, and then you're going to have a square root, and it's going to be the sum of all the numbers minus the mean. Okay, so you're going to find the sum of all the numbers minus the mean. So we would find the mean, then we're going to take each value and subtract it subtract the mean from it, and then we're going to add those up. Then we're going to square those. We're going to square those numbers. Then we're going to add it up. Okay. Then you're going to divide by n minus 1, which is however many numbers they are, minus 1, and then you're going to square root that. That gives you the standard deviation. That's kind of our formula. Now, not too worried about it right here because I can look at the graph and see what's going on. So it's 5, 10, or 15. So how far away is each typical value? And if you look at that, we don't have a very big spread because these bars are 5 each. Okay. So it says, consider 5 hours as an estimate of the standard deviation. Is it a reasonable description of a typical distance from the mean? Well, no, because you've got some of these that are way out here. Okay, if the mean was 105, this is up to 145, and this one would be, what was that, 25 away? So probably not. It's going to be greater. Should be greater is what we would say. Okay, now consider 10. What about 10? Well, if we were to go 10, we would go to here, and we would go to here. Well, that's about half of this, half of the left side. Okay, so yeah, we could say, yes, this could happen. Okay, and we would say probably yes, because that's when the greatest change occurs. And what I mean by that is here we drop way down, and here we drop way down. Okay, we go all the way down to here. So that's kind of the standard, would be the majority of your values are going to be found here, and then we have a huge jump off or drop off. Okay, so this says consider 25. We would say no, because why? Well, if we go from 25 down to here, that covers all of it. 25 gets all the data below the mean. So that's not the typical number away from the mean. That's all the data away from the mean on the left side. Okay. All right, let's go to page 2. Now, says this histogram is the greatest drop in feet for 55 major roller coasters in the United States. Would you describe this distribution of roller coasters maximum drop as approximately symmetrical or skewed? Well, this one's pretty easy to tell. This one would be, if I say whichever way you're sliding, if this is a slide, these are the steps, and then you slide off of it, that's going to be skewed right. Okay. Now, it says the mean and the maximum drop of the distribution, is that closer, or the mean of the maximum drop, is that closer to 90, 135, or 240? Well, here, I'm probably going to say 90 is going to be too small, right? We have, here would be 90. Well, there's a lot of values to the right of that and very few to the left. So that's probably not going to be the mean. 135 is going to be right in here. We have a lot of values over here, few down here, but they're spread out a lot more. Okay. So then our other option is 240. Well, there's not even that many of them to the right of it, so that one's not going to be it. So we could easily say, I think here, that 135 is the mean. Okay. Now, the standard deviation. So we're looking at 135, because that's the standard deviation, the spread according to the mean. And if we look at this, we're going to have, if we go 40 to the left, that gets us to 90. If we go 40 to the right, that's going to get us a little over 170. Okay. So that would be pretty close, right? That's a typical distance away from the mean. But if we were to say 70, well, that kind of gets everything. So no, we're going to say that it's probably 40, maybe 70, because of these outliers out here. That's going to mess with your standard deviation a good bit because of this one out here. So it may be 70. Probably because of that, I may even say that it is 70, just knowing how far away that last one is. It's kind of hard to tell when you don't have a symmetrical distribution. Okay. Now, this says we're going to pick, so we're just looking at each of these histograms over here, 1, 2, 3, and 4, and we're going to tell what is the distribution. And these are our options down here. Okay. This is A, B, C, and D. We're going to say whether it's skewed right, symmetrical, or those are only two shapes, and what the mean is and what's the standard deviation. Okay, so let's look at skewed right. So for A, we got skewed right, which is going to have to be either 2 or 4, right? But then we're going to have to look at what is the standard deviation. So what is the spread? How spread out is it? Okay, so we're just looking at the right skewed right now, so that'd be histogram 2 and 4. And then the only difference between A and D is the standard deviation. Okay? So we got to pick from the standard deviations which one of these graphs it is. Well, standard deviation of 10 means that the spread is not as great as the spread of 40, right? Or the standard deviation of 40. So since these numbers down here are much closer together, that's going to be the standard deviation of 10. These are much more spread out, and you have one down here that's like 320 or so. So that one's going to be the standard deviation of 40. So histogram 2 is going to be A. Histogram 4 is going to be D. All right? So that's got rid of those. So we can actually just mark those out. Now we're looking at only the ones that are mound shaped. So that would be 1 and 3. And once again, you have a standard deviation of 10 and 40. So we're going to look down here at see how spread out they are. Well, this goes from 0 to 200. This goes from 70 to 125. So you're probably not going to have a standard deviation of 40 when that's only a little bit, the whole spread is only, what is that, 55? Here you have a spread of 200, so that's going to be the standard deviation of 40. That'll go to 3, this will go to 1. So histogram 1 is going to be C. Nope, I'm sorry. Histogram C is the 40, so that'll be here and B. So B, A, C, D. Okay, that's all you have to do there. So first you're going to look at the shape, and then you're going to look at the spread, okay, for the questions like this. Now, this says, the histogram below shows the distribution of gasoline tax per gallon for 50 states and the District of Columbia in 2010. Describe the shape, center, and spread. So center, we're really talking about the mean, right? So here, let's look at the shape. Okay, that's probably going to be considered skewed right. Okay, now the center, if we look at it, is going to be somewhere down in through here, maybe a little bit farther to the left since it's skewed right. That means the mean's going to shift farther to the left. So let's just call it right here, let's call it 25 as the center. And if we're going to look at the spread, well, how far is the spread? Or what we would refer to as the standard deviation. Well, we could probably just say that's going to be about 10. So the spread would be 10. Your typical distance would be about 10 there, away from the mean. Okay? If you're looking at number 9, it says the histogram below shows the distribution of the numbers of automobiles accidents per year for every 1,000 people in different occupations. Describe the shape, center, and spread of this distribution. Well, if we look at the shape, we're going to have probably symmetrical. This one is probably the one that is probably the closest to being symmetrical that we've had so far. So whenever this symmetrical, you can look at the mean to be just directly straight down the middle almost. So we're going to call it 89. And remember the standard deviation or the spread is going to be how far away until you have your biggest drop off. Okay, so if we go up to 100 right here and down to about 90, or we're at 90, about 80 right here, that's kind of got it spread out here pretty even. And that's kind of the biggest change from here and here. So we'll call the spread again about 10. Now, so we're just doing an eye guess here. We're not even really trying to figure it out because we would have to do our formula for standard deviation. But we're just trying to give it a little eye test and just get as much information just by looking at the graph so far. And that is it. So you need to know basically the shapes, the mean, and the standard deviation. And what does that mean? Well, your shape is either going to be symmetrical or skewed. And it'll be left or right. Your mean or the center, sometimes they refer to it as the center. That's just your typical value. What is the most, if we were to define this set of data by one value, what would you pick? That would be the typical value. Okay? Now, standard deviation talks about the standard deviation. I'm going to call it SD. That is the typical distance from the mean. So we've picked our mean. We found our mean. Now, not every one of the data values is the mean. So how far away from the mean are the majority or the typical values? Okay. So it's kind of like we're deciding where's the center, and we're going to base everything off of the mean or the center.